All right. Hey, students. We are looking at the 9-B worksheet today. And this one is all about polygons and classifying specifically quadrilaterals in the coordinate plane. We're going to learn a lot more about quadrilaterals later this year, but this is kind of an introduction to the topic. So we're actually going to start out by skipping number 12. I don't know if it'll be on your worksheet or not, but it shouldn't be. So we're going to skip that one and go right down to number 21. What type of quadrilateral is ABCD, and how do you know? Well, here's ABCD. So let's see. We could do a whole bunch of stuff with coordinates, or we could use the graph to help us because we do have a graph here. Okay? And so if I'm thinking about the side lengths, because I can see right away that none of these sides are parallel. So I know this can't be a trapezoid. I know it can't be a parallelogram. I can just see that because anything drawn on a graph is going to be drawn to scale. That's one thing about geometry. And these sides certainly are not parallel. So then the next thing I want to do is say, well, what about the side lengths? Right? If they're not parallel, the only other kind of quadrilateral this could be is a kite. And we've got to see if it's a kite or if it's just a regular old quadrilateral. So this side is obviously 5 because we can just count those boxes. This side, we can find out the length of side CD by making this triangle right here, which is a right triangle, obviously. And it's a right triangle with side lengths of 3 and 4. Okay, and if I did the Pythagorean theorem to find the length of the third side, that would be one way I could do this. I could also put it into the distance formula, but I like the Pythagorean theorem, and I can say 3 squared plus 4 squared equals x squared. Wow, that's messy writing, I'm sorry. So that's 9 plus 16 equals x squared, or 25 equals x squared. When we take the square root of both sides, we find that 5 is equal to that side length. So side CD is also 5. And then we can see that side AB has a triangle, a right triangle that we can make there. That's going to be 1 by 3. And BC also has a right triangle that's going to be 1 by 3. And so A, B, and BC are both going to have the same length as well. So this shape happens to have 2 pairs of adjacent congruent sides, making this shape a kite. So it's a kite because it has 2 pairs of adjacent congruent sides. Right. Don't have to do as much work when we have a graph there. Here, 3 vertices of a quadrilateral are P, Q, and R. Suppose PQRS is a parallelogram. What are the coordinates of vertex S? What type of parallelogram is PQRS? Well, that's interesting, okay? So first of all, we can draw a picture of like a quadrilateral. I think that this is helpful, is to draw a picture of a parallelogram, so that we can kind of remind ourselves what's going to happen in this shape. So if this is P, Q, R, S, and we're looking for coordinate S, and we know PQR, I know that QR and PS are going to be parallel. So I know that the distance from Q to R, or not even the distance, but the direction from Q to R is going to be the same as the direction from P to S. So if I started at Q, 2, 4, and I went to R at 1, 0, my x values would go down 1 because 2, 1, the x value here is 2, the x value here is 1. So my x values would go down 1, And my y values go from 4 to 0, so they would go down 4. So to go from Q to R, I go down 1 on the x and down 4 on the y. To go from P to S, I need to do the same thing. So from P to S, x's will go down 1, y's down 4. So for my p value, I have -2, 3. And I have to go down 1 for the x's, down 4 for the y's. -2 minus 1 is going to be -3. 3 minus -4, 3 minus 4 is going to be -1. So my s coordinate is going to be -3, -1. It's kind of interesting and confusing. It's something that you could also do on a graph if you wanted to do it on graph paper, and that would be fine as well. But either way, you're going to find out that your s coordinate, in order to make this shape a parallelogram, must be -3, -1. Then it says, what type of parallelogram is PQRS? So we already know that in a parallelogram, the opposite sides have to be the same length, no matter what. We should find out whether the adjacent sides are the same length, because that could tell us some information. That could tell us whether this is a rhombus or not, if the adjacent sides are the same length. So we're going to go ahead and find the side lengths of PQ and QR. Those are some adjacent sides. So PQ, let's see, to find the side length there, that's going to be -2 minus 2 squared plus 3 minus 4 squared. I'm going to try and do this really small because I've got quite a bit of work to show here. So that's going to be -4 squared plus -1 squared, which is going to be the square root of 16 plus 1, or the square root of 17. So the length of PQ is the square root of 17. Then we'll try an adjacent side, QR. So QR is going to have a length of, well, we've got -2 minus 1 squared plus 4 minus 0 squared. So this is a +2 minus 1, right? Because the x value for Q is +2, so this is a +2 minus 1. So that's going to give us the square root of 1 squared plus 4 squared, which is going to be the square root of 1 plus 16, which gives us the square root of 17. So now that we know that the adjacent sides are the same length, that means that all 4 sides of this parallelogram will be the same length, right? We know that the adjacent sides are the same length. We know that the opposite sides will be the same length as those, and so they're all the same, which means this is at least a rhombus. Then we have to check to see, well, if a shape is a rhombus, it's also possible that it's a square, because if those side lengths are opposite reciprocals, or if those slopes are opposite reciprocals to one another, that makes right angles, which makes it a square. So let's find the slope of 2 sides that are adjacent to one another to find out whether this is a square or not. So first we can find the slope of PS. You could do any 2 adjacent sides. So the slope of PS is going to be 3 minus -1 over -2 minus -3, right? And that's going to give us 4 over 1, which is a slope of 4. We also have to find the slope of PQ, or any other adjacent side. I'll just use PQ here. The slope of PQ is going to be slope formula 3 minus 4, y2 minus y1, over negative 2 minus 2. It's going to be negative 1 over negative 4, or 1/4. Positive 4 and positive 1/4 are not opposite reciprocals, so this does not have right angles. It's not a square, but it is a parallelogram with all four sides the same length, so it is a rhombus. There we go. Number 25, suppose PQSR is a parallelogram. What are the coordinates of vertex S? What type of parallelogram is PQSR? So we need to do the same thing here, but this time our parallelogram is named in a different order. And when our parallelogram is named in a different order, that means that we're going to have to make sure that we find the new coordinate. So we'll go PQSR instead of PQRS. Now, if we are trying to find S, the change from P to R is going to be the same as the change from Q to S, because I know PR and QS are parallel in a parallelogram. So I've got to find the change from P to R, right? So P is at negative 2, 3, and R is at 1, 0. So negative 2, 3, 2, 1, 0. That gives me an X change. From negative 2 to 1 is a plus 3X change. From 3 to 0 is a minus 3Y change. And so I'll do the same thing to go from Q to the new S point, right? So right now Q is 2, 4. So I'll start at 2, 4, and I'll go to a new coordinate point by adding 3 to the X's and subtracting 3 from the Y's. So that's going to be 2 plus 3 is 5. 4 minus 3 is 1. So my new S coordinate is 5, 1. And we'll use that. Oops. Whoa. There we go. We'll use that in our work. So we've got to find out what kind of parallelogram PQSR is. It's going to be the same process as last time. I'm going to want to find the distance, not the distance, but kind of, yeah, the length of PR and the length of RS, or two other of the side lengths. I'm going to use one I already calculated from up above. I'm going to find the side length PQ, because I know that PQ is the same as PQ up above, because those two coordinate points are the same. So PQ has a length of the square root of 17. I already calculated it up above, so I don't need to do it again. And then I need to find one that is adjacent to PQ. So how about QS? And to find the side length of QS, I have to find the distance formula again. So QS is going to be 2 minus 5 squared plus 4 minus 1 squared. That's going to give us the square root of negative 3 squared plus 3 squared. That's the square root of 9 plus 9, which is the square root of 18. Those are not the same length. So since the adjacent sides are not the same length, I know this is not a rhombus, because in a rhombus, all the sides are the same length. So this is not a rhombus, but it could still have right angles and be a rectangle. So I've got to go through and I've got to find the slopes of some of these sides that are adjacent to one another to figure out whether these angles are right angles, and we have a rectangle on our hands. So let's go ahead and find the slope of PQ, because I already found it up above, and that was 1/4. And then we'll find the slope of a side next to it. So maybe the slope of PR, you can use whatever one you want. The slope of PR is going to be 3 minus 0 over negative 2 minus 1. It's going to give us 3 over negative 3. or negative 1? Well, 1/4 and negative 1 are not opposite reciprocals. So since we know it's not a rhombus, and we know it's not a rectangle, then that means the only possible name for this is just a parallelogram. It's not any special kind of parallelogram. So just a parallelogram. And that'll be our answer. I don't know why it goes up like that or down like that. There we go. All right. 26. An architect overlays a coordinate grid on her plans for attaching a greenhouse to the side of her house. She wants to locate point D so that ABCD is a trapezoid and the line CD is perpendicular to the house. What are the coordinates for point D? All right. So we're going to have a trapezoid, and it's going to go A, B, C, D. So here's A, B, and here's B, C. And we don't know where point D is going to be yet, so we can't finish our shape yet, okay? But we do know that CD is going to be perpendicular to the house. So our first step is going to be to find the slope of the house. So find the slope of the house, okay? And we've got 2 points on there. We've got 2, 8, and we've got 0, 0. And so to find that slope, we've got 8 minus 0 over 2 minus 0, which gives us 8 over 2, a slope of 4, okay? Since the slope of CD is perpendicular to the house, then CD slope will be negative 1/4. All right. And if we know the slope of CD and we know one of the coordinate points on line CD, we can go ahead and we can combine those together. Okay. So let's see here. We want an equation. So we want y equals negative 1/4 x plus b. And we're going to use the coordinate point 2, 8 as our xy coordinate. So 8 equals negative 1/4 times 2 plus b. So 8 equals negative 1/2 plus b. Add 1/2 to both sides. We'll use mixed numbers here. So 8 is the same thing as 16 halves plus 1/2 is 17 halves. That's our b value. So the equation for CD is going to be y equals negative 1/4 x plus 17 halves. That's one equation that we're going to need. We're going to need to find 2 equations because we need to know where those 2 equations meet up to find point D. So once we find the equation of CD, or not the equation of CD, but the equation of one line that we need to find, which in this case is the line from C to some point over here, we're also going to need to find the equation of AD, wherever that needs to be. So the slope of AD we already can find as well, because the slope of AD to make the shape a trapezoid is going to need to be the same as the slope of the house, okay? Trapezoids have one pair of parallel sides, and this is the pair of parallel sides we're going to need to find. The slope of the house is 4, so the slope of AD is 4. We also know that AD passes through the coordinate point 4, 0, so we can use that as the point in our equation that we find. So we'll find y equals 4x plus b. We'll use the point 0, 4 to say 4 equals 4 times 0. Oh, I did that backwards, sorry. Our y coordinate is 0. So 0 equals 4 times 4 plus b. So 0 equals 16 plus b. Subtract 16. negative 16 equals b. So our equation for this one is going to be y equals 4x minus 16. Now that I know that the equation for CD is this equation, and the equation for AD is this equation, I need to find where those two equations meet. So I'm going to set those two equations equal to one another. And I'm going to say, where does negative 1/4 x plus 17 halves equal 4x minus 16? You know what? I'm going to deal with decimals instead. So negative 0.25x plus 8.5 equals 4x minus 16. We'll go ahead and solve this. So I'll add 0.25x to both sides, and I'll add 16 to both sides. So that'll be 24.5 equals 4.25x. Divide both sides by 4.25. And that's going to give us an x value of, let's see, 5.76. Once I find the x value, I also have to plug it in to find the y value. So I'll plug it into this equation over here, right? This is just solving systems of equations 101. So y equals 4 times the x value of 5.76 minus 16. That's going to be y equals 7.04, right? Did I do that right? Yeah. Okay. So my equation is going, or my point D is going to be equal to the coordinate point 5.76 comma 7.04. Just like that. That's a lot of work just for one problem, but that's okay. We just have some longer problems in this section. If we wanted to, we could show where this is. So 5.76, 7.04, something like this, I think. Let's see. Like right there. And we could then draw our shape in. There we go. Number 30, quadrilateral JKLM has vertices. Which is the most precise classification of JKLM? So we're going to have to go through all our stuff here. We're going to have to find the slopes of these lines in this shape. And we're going to have to find the equation, or not the equations, but the lengths of the lines here. So we'll start by finding the slopes. I think that's going to be the fastest way, because then we can find out whether this is a quadrilateral or not. So we can go ahead and say, all right, find the slope of JK, find the slope of KL, find the slope of LM, and find the slope of JM. Right, or MJ. So those are the four sides. Sometimes I like to draw myself an example quadrilateral. It doesn't need to be any specific shape of quadrilateral. I just like to know which sides go where. So I draw in my sides. So I know there's a side JK, a side KL, a side LM, and a side MJ. So to find the slopes of these, JK is going to be 1 minus negative 2 over 7 minus 1, which is 3 over 6, or 1/2. So the slope of JK is 1/2. KL is going to be negative 1 minus 1 over 8 minus 7, which is going to give us negative 2 over 1, or a slope of negative 2. LM is going to be negative 4 minus negative 1 over 2 minus 8, and that is going to give us negative 3 over negative 6, which will give us 1/2. And Jm, or Mj, is going to be -4 minus -2 over 2 minus 1, and that is going to be -2 over 1, which is -2. Hey, take a look at this. Our slopes are opposite reciprocals of one another. And if our slopes are opposite reciprocals of another, we know that they are going to be right angles, which means any quadrilateral with right angles is going to be at least a rectangle. Okay, so at least a rectangle. We also notice, of course, that there are two pairs of slopes that are the same, which means this is a parallelogram. And then from there we get to our opposite reciprocals. So at least a rectangle. And we should find out if this rectangle is also a square by testing to see whether our sides are the same length. So we'll test two adjacent sides to see if they're the same length, and if they are, then this happens to also be a square. Wait a minute, do we even need to test that? We don't, because this is a multiple choice question, and square isn't a choice. So we know that this has right angles, and the only shape up here that is specific enough to have 4 right angles is a rectangle. So that's all we need to do. It could be a square. We don't even know, but we don't need to know because it is a multiple choice question. All right, if there's any questions that you have about this worksheet, I know some of these questions were a little bit tricky, especially at number 26. And actually, I think they were all kind of tricky. So if you have a question for me, please let me know and we can go over it in class. All right, thank you so much and have a wonderful day.